Good morning, ma'am.
Good morning, Elia. How are you?
Fine, ma'am. Ma'am, how are you?
Fine, thank you. Hello, Ruba. I can't hear your voice. Okay. Hello, Halima. Nashra.
Hello, ma'am.
Sahib. Saud Rafaqat.
Hello, ma'am.
Hello, beta. How are you?
I'm good, ma'am.
Amna Maham. Amna Maham doesn't seem to have a mic. Okay. So let's take I'll give you a problem first, and then I will take your attendance. Okay. So I am going to share the board with you. Okay.
Hello, ma'am.
Hello, beta. Who is this? Sahib. How are you, Sahib?
Ma'am, I'm good. आपने मुझसे पूछा नहीं.
मैंने पूछा था आपको पता नहीं चला.
Assalamu alaikum, ma'am.
वालेकुम सलाम.
Oh, okay, right.
Okay, yeah. Okay. Hello, Amna. Was this Amna? Okay, so as I said, we'll start with a problem. Like you know that we are discussing, practicing the different concepts and problems in chapter number 5. So I'm going to start with a problem, and this is of the universe from the Hubble constant. Okay, so this is the question. I would like you to think about this, and meanwhile I'll take your attendance and then we can discuss this. Okay, and whoever helps solve this question will get a point. Okay, can you see the board?
Yes, ma'am.
Yes, ma'am.
So try to understand this and then we'll discuss it, and meanwhile I'm going to take your attendance. Okay, so Ahmad Hassan, Fahad bin Ahmar, Hafiza Aisha, Ali Musa, Mahnur Amjad, Nimra Arif, Sayyid Azad Asad, Farooq Ahmad, Khabar Gill, Laiba Khalid, Sahib Khan, Ilyas.
Present, ma'am.
So Sahib, there seems to be a lag maybe in your case. Is that the case? You know, between the speaking. Iria Shafkat.
Ma'am,
Present, ma'am.
your voice is low.
My voice is low.
Ma'am, Elia Shafkat present.
Okay, good. Amna Maham,
Amna ma'am present, ma'am.
Ashna, Aruba,
Present, ma'am.
okay. Halima,
Present, ma'am.
Nawab Sadiq,
Present, ma'am.
Sumavi Tahir, and Saud Rafaqat.
Present, ma'am.
Miss Nasha should also present.
Right. Okay, so let's come back to the problem. So did you try to understand what this is about? You know that we've completed chapter number 5. Of course, this is based on the concepts that we studied in chapter number 5. How do you think we can solve this question?
मैम Amna ma'am. मैम इसमें हुक्स कांस्टेंट को देखना है ना जो हमने पढ़ा था.
Yes, because we have to think about the Hubble's constant. That's a good idea. That's a very good idea. So think about the Hubble's constant. It's related to this problem, right? So it's also mentioned over here. So, okay, you have to think about this. Okay. Okay. So what is the symbol of?
Ma'am, is it 20 kilometers per second?
Amna, there's too much noise on your side. Can you? It's a little bit difficult to understand what you're saying. So can you please say it again?
Ma'am, I asked, is it 20 kilometers per second?
What is 20 kilometers per second? The Hubble's constant.
Ma'am, yes.
Let's check. So where did we study the Hubble's constant in this chapter? Let's go there. Okay, if you look at page number 10, right? I'm going to share the book, okay? So you share in the book and here, okay? So now you can see the book, okay? So here you can see the Hubble's relation, okay? In this case, this is the Hubble's relation. And according to this, V is the velocity and D is the distance, okay? And H naught is the Hubble's constant, okay? So let's use this. So we are going to use the Hubble's law. And in this case, the Hubble's constant, depending on the method, H naught lies between 50 kilometers per second megaparsec and 100 kilometer per second megaparsec. Okay, so this is all given in your book. So let us use this. So V is equal to H naught T. This is the Hubble's relation. In this case, V is velocity. Okay. And D is the distance. H naught is the Hubble's constant, right? And its value is also given over here. Okay. Okay, now try to understand how you can use this.
मैम आपकी आवाज बहुत लो है.
Okay, I'll try to increase it. Okay. Okay. What do you think? Can you hear me now?
Yes ma'am, it's better.
So now you know that we were talking about the Hubble's relation, and the Hubble's relation, as you can see, is V is equal to H naught D. In this case, H naught is the Hubble's constant, V is the velocity, and D is the distance, right? Okay. Now let's try to understand this.
Yes ma'am.
Okay. You can see that this is used in many different places. Now here you can see this. You can see that we can consider a galaxy at a certain distance. Let us say d is equal to 1 megaparsec. Let us take the value of h naught as 65 kilometer per second, and using these values we can calculate the velocity. Okay, okay.
Yes ma'am.
Yes, ma'am.
Okay, so try to calculate this yourself and check what is the velocity that you're getting. Did you get the value of the velocity?
Ma'am, it's 65
65
kilometers
per second.
per second.
If you use this data that is given, you use a distance of a galaxy as 1 megaparsec, and you use h naught as 65 kilometers per second megaparsec inverse. Then if you substitute these values and you calculate the velocity, it comes out to be 65 kilometers per second. You remember the parsec? The parsec was the unit defined in the beginning of this chapter, right? So this is the conversion between a parsec and a meter. Also remember that in this case, you're using different units, so be careful how you're going to. Now, whenever you know there's velocity and distance, a related term is time, okay? So we know that velocity is defined as distance divided by time, okay? So time will be equal to divided by velocity. You can calculate the time. In the value of the velocity, you have the distance, you have the time. This time according to the effect.
एक्सक्यूज मी मैम.
Yes, sound.
मैम ये पॉइंट दोबारा समझा दीजिएगा. ये जो फार्मूला ड्राइव किया वो आवाज बहुत कम आ रही थी आपकी.
अच्छा. Okay. Okay, right. So as I was saying, we are using the Hubble's relation. The Hubble relation gives us the relationship between velocity and distance of a galaxy. For example, the question is, how do we estimate the age of the universe? Of course, we do not have a direct method to do this. So we will try to find an indirect method to do this. So a way of doing this is to consider a galaxy, because from time to time in books you can get information about the distances of galaxies, and using this relation, if you know the distance of a galaxy and using the Hubble's relation, we know the Hubble's constant, we can calculate the velocity of a galaxy. Okay, so that was the first step. In the first step, we calculated the velocity of a galaxy using the data that we are given, that the distance, we substitute the value for the distance of the galaxy and the Hubble's constant. We get the velocity, and when you have the velocity, then you have the simple relation from the beginning. Even before you came to this course, you know that velocity is equal to distance or displacement divided by time. So if we have the distance, we have the time, sorry, we have the distance, we have the velocity. So we can use this to find the time. So substituting this value here, the distance, as we just said, we can substitute its value, and over time, can you do this yourself? Put the value of distance, put the value of velocity, and calculate the time. And if we do this with the SI system, we get the time in seconds. But as you know that in the universe, in the cosmos, seconds is a very small unit of time, and therefore we convert it into years in this case. Okay, so we have the time. If we have the time, if the universe began as a point of energy, this is also the age of the universe. We can consider this to be the age of a universe, right? A simple equation to calculate the predicted age of the universe in years for any Hubble constant, it can be calculated in this way. Okay, so again, like we have already discussed the problem, and you can also see the information. You have a lot of information related to this in the book chapter as well, but again, you will have to practice this yourself. Also, you know that whenever you have these answers or values in the book, you should also calculate them yourself to understand and practice and verify how you get these values. Is that clear? Okay.
Yes, ma'am.
Good. Okay, so
Yes, ma'am.
Yes, ma'am.
thank you for helping in this problem. So Amna Maham gets 1 point for this. Now let's look at another problem. Okay. Okay, I'm going to give you a problem and you think about this. So I'm going to share the board again. Okay, so now we are talking about this question. Okay, so you can see the question, right? So the question is,
Yes, ma'am.
okay, so above what energy do gamma rays produce a proton and an antiproton? So please think about this, take a minute, and then we will start the discussion. And tell me your name when you want to answer or comment or say something, okay?
मैम मैम ये पेज नंबर 19 पे एक्सप्लेन तो किया हुआ है और यानी कि टेम्परेचर को बता रहे हैं.
There's a lot of noise. Please try to shift your position to a place which is less noisy.
Yes ma'am, is it better?
Yes, it's good now. Okay.
मैम मैंने बोला पेज नंबर 19 पे इसका दिया हुआ है कि हाउ गामा रेज प्रोड्यूस प्रोटॉन एंड एंटी प्रोटॉन.
Okay, यहाँ
It's
पे
about the
रुको. Let us look at page number 19. क्या लिखा हुआ है? Okay. Stay with us. Let us look at what you're saying on page number 19. Okay, so page number 19. Page number 19. Okay. Right. Ji Amna, I'm going to share the book. You share this. Share. Okay, this is page number 19. Yes, can you explain what you were saying? Amna?
yes ma'am, this is the page I am talking about.
Yes. Tell us what you're saying about this page.
मैम थिंक कि इस पेज में समझाया हुआ है कि वो कैसे गामा रेज से प्रोटॉन एंटी प्रोटॉन होते हैं. एक स्पेसिफिक टेम्परेचर की वजह से जो है ना ये प्रोडक्शन होती है. अभी मुझे थोड़ा सा क्लियर नहीं हो रहा, बताना नहीं आ रहा, तो वो टॉपिक मैंने
But you're on the right track. ठीक है. Okay, we can discuss this further. This page, this is the topic here is annihilation of protons and antiprotons. Okay, so at a certain temperature, at a very high temperature, you see that protons and antiprotons collide to form high energy gamma rays. So this is what our question is about, right? So it's already explained here. The gamma rays continuously produced proton-antiproton pairs. The production and destruction rates were in equilibrium so that the number of particles being produced was the same as the number of those being destroyed. So once the temperature had dropped below the threshold temperature for protons, pair production ceased to produce new protons. So collisions continued to happen and annihilated equal number of protons and antiprotons. The universe was left with a small excess of protons. So our question is about the beginning part of it. Now the later discussion is about how the universe evolved, right? By the processes of proton, antiproton, annihilation, the gamma rays producing these pairs, and how, for example, we later on got the elements that we have, right? So all of this is explained here, right? And this is again happening for many other particles as well, not just for protons and antiprotons. For example, it can happen with electrons and positrons, for example. So this is the particle and antiparticle pair. So proton antiproton is a particle antiparticle pair. Similarly, electron positron is a particle antiparticle pair. And similarly, you can have reactions involving neutrino, antineutrino, and so on. So these are different kinds of reactions that have been taking place in the universe, right? And of course, this is related to the evolution of the universe. It's related to temperature, and it's there's a very interesting discussion here related to the Big Bang and how these particles led to the evolution of elements and the nucleosynthesis that we've been talking about. But let's concentrate on the first part of this discussion, which is the first paragraph here. So this is about the question that we are talking about. So Amna, yes, you pointed in the right direction. Okay, so this is about this. Now, what will be the next step? Let's think about this.
तो मैम आपके सवाल की समझ नहीं आई.
अच्छा, सवाल आपके सामने है? नहीं. Let me share the question with you. आपको ठहरो. So this is the question. So अब हमने ये solve करना है तो किस तरह से solve करेंगे? That's my question.
मैम
Yes.
मैम ये जो प्रोटॉन एंटी प्रोटॉन जो गैमा रे से एनर्जी प्रोड्यूस करेंगे वो 938.3 मेगा इलेक्ट्रॉन वोल्ट होगी।
अच्छा, ये कैसे पता चला आपको? थोड़ा सा
मैम ये इधर मैम ये मेंशन हुआ है इधर बुक में
किया हुआ है, ठीक है। थोड़ा सा आप इसको सोचें ये किस तरह से इन्होंने किया है, ठीक है?
यस मैम।
थोड़ा सा
और फर्दर स्टेप में मैम ये इसने मेगा इलेक्ट्रॉन वोल्ट में दिया उसको एनर्जी को इन्होंने वो जूल्स के उसके ऐसे यूनिट में कन्वर्ट कर लिया है।
हाँ, ठीक है। अच्छा, और हमने we've done a lot of problems in which we use the Einstein's equation to convert mass into energy, है ना? याद है आपको?
यस मैम।
Okay, so I will share the page. कौन से पेज से पढ़ रहे हैं आप?
मैम ये बुक का पेज है 263।
263. Just a moment. Okay, let's share the page. So now you can see the book, and the page he's talking about is 263 page. Wait, just a moment.
यस मैम 2 पेज पीछे से।
ये वाला नहीं, ये तो हबल वाला है। अच्छा, इससे पीछे, यस, ये वाला। अच्छा, अगेन आई वुड लाइक टू ड्रॉ योर अटेंशन टू द फैक्ट कि यहाँ पे भी फॉर एग्जांपल इससे मिलता जुलता टॉपिक जो है वो एक्सप्लेन किया हुआ है। यू कैन सी दिस। तो जैसे ये वाला टॉपिक सॉल्व किया उसी तरह से आपने प्रोटॉन एंटी प्रोटॉन सॉल्व करना है। डू यू अंडरस्टैंड दैट? दिस अगर इफ यू लुक एट दिस पेज, इससे एक पेज ऊपर pair creation and pair annihilation, you can see this for the electron and the positron. तो जिस तरह से इलेक्ट्रॉन पॉजिट्रॉन को सॉल्व किया है उसी तरह से हम प्रोटॉन एंटी प्रोटॉन को सॉल्व कर सकते हैं। इज दैट क्लियर?
यस मैम।
बिकॉज आपको पता है कि फॉर एग्जांपल एनर्जी एंड मास कैन बी कन्वर्टेड, ठीक है ना? सो कोई भी मास हमारे पास होगा उससे हम एनर्जी की वैल्यू निकाल सकते हैं, कोई भी एनर्जी हमारे पास होगी उससे हम mass की वैल्यू निकाल सकते हैं। Is that clear?
Yes, ma'am.
Try to understand this example that I am showing you about electron positron. ठीक है?
मैम नीचे इन्होंने एग्जांपल भी दी है।
हाँ, बिल्कुल दी हुई है। Yes. तो एग्जाम्पल दी हुई है, बट आई वुड लाइक यू टू प्रैक्टिस दिस सो दैट यू अंडरस्टैंड इट, क्योंकि जब आप खाली पढ़ने से समझ नहीं आती, करने से समझ आती है। इज दैट क्लियर?
यस मैम।
तो आप खुद से इसको सॉल्व करके देखें आपका क्या आंसर आता है। इज दैट क्लियर?
यस मैम।
Okay, in order to understand this, I would like to draw your attention to the fact, what is the mass of a proton?
Ma'am, in kilograms?
किलोग्राम में बता दो, किसी और यूनिट में बता दो।
Okay, so in kilograms it is 1.67 multiplied by 10 raised to power minus 27
kg, है ना?
Yes.
Very good.
Yes, ma'am.
तो ये किस पेज से देखा आपने?
ये पेज इस बुक में नहीं है. I mean, इस
बुक में भी दिया हुआ है. कहाँ पे दिया हुआ है?
like एग्जैक्टली मुझे पेज नंबर नहीं पता, मैंने मोबाइल पे ओपन किया है.
अच्छा, चलो कोई और बताए.
मैम क्वेश्चन बता दीजिएगा.
What is the mass of a proton? अच्छा, इसके लिए
मैम ये गिवन नहीं होगा.
हाँ, तो ये इसी चैप्टर में गिवन है ना, वही तो मैं आपको बता रही हूँ.
मैम 938.3 mass of
ये
proton.
तो एंटी प्रोटॉन का बता रहे हैं ना, खाली प्रोटॉन का पूछ रही थी मैं आपसे.
मैम इधर तो दोनों के इकट्ठे ही
इधर तो
मेंशन.
दोनों का बताया हुआ है ना, क्योंकि द क्वेश्चन इज अबाउट दैट. बट इन ऑर्डर टू अंडरस्टैंड दिस, आई वांट यू टू अंडरस्टैंड.
मैम 1.67 10 power 27 ये.
एक मिनट.
मैम mass of electron is 0.511.
आप जाएं पेज नंबर 260 पे, ठीक है? So if you go to page number 260, for example, let's see. Let me share this with you. Page number 260 में. So what can you see? You can see the. What can you see right now?
Nothing, ma'am.
Acha,
Nothing,
ma'am.
I'm sharing the board, okay? No, sorry, I'm sharing the book. So you can see here on page number 260, or it's page number 14 of the book. So here you can see the mass of a proton. In this case, you can see it is 1 U. Okay, there are different units that we can use, and in this chapter we've been using different units. We've been using the unit of U, or sometimes it is called AMU. We have also been using the SI system, which is kg, and we have also been using the system whereby by the Einstein's equation, this can be written as MEV U inverse. So we have been using all these units. So in this case, you can see the mass of a proton is 1 U, and this is equal to 1.67 into 10 raised to minus 27 kg. And when this is converted into mass, the Einstein equivalent in this case is 931.49 MeV U inverse. Okay. So using the same method, we can find this for the proton, antiproton, and that's how you got the answer here of 938.3 MeV C in raised to minus 2. Okay, so now you understand how you got this result, right? So therefore, the energy above which each of a pair of gamma rays can produce a proton-antiproton pair is given by this value. So now I have explained the concepts related to this question. So please practice and understand these concepts, and then you will understand how we solved this problem. Okay. Now the next part of this problem is, what is the temperature equivalent? The next part is, what is the temperature equivalent to this energy? So this question can also come as, for example, you can, the question I gave you was above what energy do gamma rays produce a proton and an antiproton? I can also ask you above what temperature, for example, gamma rays produce a proton and an antiproton. So how will you do that? You're now going to convert energy into temperature. Is that clear?
Yes, ma'am.
So how do you convert energy into temperature? We have studied a small equation in this chapter, how we can convert temperature into energy or energy into temperature. So this equation here again, which has been explained in this chapter, is E is equal to kT, where K is a constant and its value is given. Okay. So
Yes, ma'am.
using this equation, we have the energy, we can calculate the temperature. Is that clear?
Yes, ma'am.
Okay, good. So can you tell me the page where we studied E is equal to kT? Do you remember the page where we studied this? If you go in the beginning of this chapter, for example, if you go on page 262, right, you will see that kinetic energy is given as kT. Remember?
Yes, ma'am.
So you can, again, all of this discussion, the problem, the concepts are from various concepts that we have studied in this chapter. So please properly study and prepare the chapter. It's very interesting. Okay. It's definitely not difficult or boring. Actually, it's interesting when you understand. It becomes boring or difficult when you don't understand something. When you study something with an understanding, then it becomes interesting. So here you can see on this page, one page before, we have the equation for kinetic energy is equal to 3/2 kT. So here K is the constant, which is known as the Boltzmann constant, right? You can see the book, okay?
Yes, ma'am.
Yeah, so this is the constant I'm talking about. And this equation in general can also be written as energy is equal to kT. So sometimes we write it as 3/2 kT, or it can also be written as equal to kT. We know the value of K and we know the value of E, therefore we can find the temperature T. Okay? So please practice this. This is your homework. Practice the concepts in this chapter, the small equations. We just used two small equations today. One was the Hubble's relation and one was this conversion of